Welcome to Endless Learning Training Series, the membrane-based desalination technology.
In this video we will study about differential pressure level transmitter. What is a zero suppression in level measurement? What is a zero elevation in level measurement? What is a wet and dry leg and its difference between applications of differential pressure transmitters in open and closed tank? DP level transmitter. There are many different technologies available, but the most widely used is differential pressure for level measurement. Basic principle: differential pressure level. Measure the liquid level in a tank by measuring the pressure generated at the bottom of the tank. The relationship between the measured pressure and the level is expressed by level H equals dP/Sg, where Sg equals specific gravity of the liquid and dP equals differential pressure measured. It's indirectly measured by monitoring the pressure exerted by the column of liquid. Open tank application. The high-pressure side of the level transmitter is connected to the base of the tank while the low-pressure side is vented to atmosphere. P high equals PATM plus SXH, P low equals PATM, PATM equals atmosphere pressure, S equals specific gravity of the liquid, H equals height of liquid column, M differential pressure dP equals P high, P low equals SXH. The level transmitter can be calibrated to output 4 mA when the tank is at 0% level and 20 mA when the tank is at 100% level. Zero suppression. For a suppressed zero range, the amount the measured variable zero is below the lower range value. It be expressed either in percent of span or in units of measured variables. Suppression equals Sxg, where S equals height of leg, G equals specific gravity of fluid in leg. In some cases, the level transmitter has to be mounted X meters below the base of open tank. The liquid in the high-pressure impulse line exerts a constant pressure, P equals Sxg, on the high-pressure side. When the liquid level is at H meters, pressure on the high-pressure side of the transmitter will be P high equals SXH plus SXG plus PATM, P low equals PATM atmosphere pressure, dP equals PHLGH, P low equals SXH plus SXG. The transmitter has to be negatively biased by a value of minus SXG, so that the output of the transmitter is proportional to the tank level, SXH, only. This procedure is called zero suppression. Zero elevation. For an elevated zero range, the amount the measure variable zero is above the lower range value. It may be expressed either in percent of span or in units of measured variables. Elevation equals Exg, where E equals height of leg, G equals specific gravity of fluid in leg. When the transmitter is elevated above the process connection point, it will most likely see a negative pressure, vacuum, with an empty tank owing to the pull of liquid in the line leading down from the instrument to the tank. This type is not recommended. In the closed tank application, there are two methods in closed tank DP level measurement, dry leg method, wet leg method. In the closed tank, a gas or vapor phase exists on top of the liquid. The gas pressure must be compensated for. A change in the gas pressure will cause a drifting change in transmitter output. Compensation can be achieved by applying the gas pressure to both the high and low pressure sides of the level transmitter. P high equals P gas plus SXH, P low equals P gas, dP equals P high, P low equals P gas plus SXH, P gas equals SXH. Dry leg method is used in normal closed tank where vapor is not condensate and temperature of process is equal to atmospheric temperature. The main disadvantage of the dry leg that restricts its use is the frequent maintenance that is required. Periodic draining of the condensate in the knockout pot will ensure that the impulse line is free of liquid. To exerts extra pressure on the low pressure side of the transmitter due to condensate may form, due to temperature variation. Wet leg method. Wet legs means where both sides, legs, are filled with liquid. Wet leg method is used where vapor has a tendency to make the condensate and temperature of process is high or low from the atmospheric temperature. The gas phase or vapor will condense in the wet leg. This maintains a constant hydrostatic pressure on the low pressure side, LP, of the level transmitter. This pressure, being a constant, to be compensated during field calibration. Wet leg method. Wet legs with zero suppression, as shown. Transmitter configuration. Set the range of level with help of common local parameter setting in transmitter. Tag number, unit of measure. Set LRV, for milliamperes, to 0 mm water column, 0%. Set URV, 20 milliamperes, to 1000 mm water column, 100%. Damping time, PV display unit. Calibrate LRV, requires applied pressure. Calibrate URV, requires applied pressure. Thank you for watching this video.